So key, hex, and binary. Then how networks actually work, and then some miscellaneous stuff. I'm just gonna talk about some basic stuff, and then I'll take any questions that people are confused about working on Bandit. So the first thing is ASCII, hex, and binary. So who knows what like those three things are? So who knows what ASCII is? You.
It's like American standard something. It's basically like the code that like sets characters, and it's like each number is assigned, or each character is assigned a number. It's like 1 through like 256, I think. I'm not sure exactly. But
it also has like a big color field to it, I believe. Right?
What do you mean by that?
Like I remember it might have been like an article or something where like people could there could be values hidden within like where like certain colors can be represented by like an ASCII number. Maybe it's hex.
That's hex.
Yeah, I don't know honestly. So ASCII is literally just like these characters. So like you said, it's like the American Standard code something blah blah blah. In like the 90s and 80s, all the keyboards were configured differently. So when you typed a key, it like responded to something differently. So they're like, hey, we need this to be the same everywhere. So they came up with ASCII. But like he was saying, all the numbers have integer representations because computers read only in ones and zeros. So they all need to be able to be represented as an integer for them to actually like work. So the ones and zeros is what we call binary because it's base 2 math, right? So the highest number you can go is 1, the lowest number you can go is 0. In ASCII, the decimal representation, that means 0 to 9, that's base 10 math, that's like what we normally do. And then there's hexadecimal, which is base 16 math, which goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Yeah. So you can be a freak like Cade and just know everything, like all the stuff, or you could be a normal person and look up like ASCII tables. And if you look up an ASCII table, you can see like the actual representations of things. I'm gonna show it. I know what you're talking about. So like for example, a capital A is a 41 in like normal or in hex and a 65 in normal like numbers. Cool. Okay. Goodbye, Lance. What Cade was talking about is you could be a real cool person and actually do. Who remembers man? Like everybody remembers man pages, right? Man.
Yeah.
We could do man ASCII and come up with an ASCII table. Okay, that's what you're talking about, right?
Yeah.
Mm-hmm. So, and then it shows you the ASCII table. So, right, like zeros are null values, which means like they're nothing. A, right? So we see A, the decimal version is 65, the hex version is 41. Okay. Hex is demonstrated by an OX and then the number, so like OX41. If we use Python, we can actually see like how the numbers are evaluated. So we can say OX41, which should be a 65, and it'll evaluate it to the decimal number 65. Okay. This is important because like this is how computers like translate information. So once you get like a little bit further in Bandit, so you may have already gotten there, you may notice like a hex dump. The hex dump shows us information from a file that may not be ASCII printable, right? So not every character in a file is ASCII printable because it's probably like a number that's outside the ASCII range. So hex allows us to see those things in that file so that like we're not just reading garbage. So let's see if I can find a file in here like that. For example, this picture, right? If I cat the picture, I get like a bunch of garbage and I can't see it yet. The question marks mean they're not ASCII printable characters, but you can see some of the characters were printed. If I use the command xxd, I hate that, so I'm going to use hd instead, which just means hex dump, and do not so meta. I can see the hex dump of this image, and so I can see like the corresponding hex. And if it's not a printable character, so 1C shows up as a dot. 1C is not outside the range, but 1C is not a printable ASCII character. So if we go through here and we look for 1C, we can see that 1C corresponds to a file separator, which is, I don't even know what that is. I forgot. But like, it's something that's integral to the way computers talk. So all these like here are like integral to the way computers talk, and so sometimes they don't always show up, but some of these do. So like tabs, they'll show up, new lines, backspaces, stuff like that. Carriage return. A carriage return is like the same thing. It's kind of the same thing as a new line. It's kind of a Windows thing also though, so it's a little weird. But other things like the data link escape, the device control, all that stuff like does not have a printable value, so it shows up as a dot. But the hexdom allows us to actually know what those values are. That way, instead of catting it, like we can understand that. Does anybody have questions on that? Why we use ASCII, why we use hex, and why we use binary? Yeah.
What is that whole column on the right on the
when I did the HD?
Yeah, when you did the HD.
Yeah, that is the like ASCII version of it. Okay. So anything that doesn't show up, anything that's not printable, so like 0, 0, we said that was null. It's not printable, so it shows up as that.
Okay.
But this O is printable, or plus is printable, so it does pop up. So like you can see like the actual printable things in here. Does that make sense?
Perfect. Thank you.
Yeah. Anybody else? No? Okay.
What's the command again for that? To
It's-
pull up the ASCII table?
To look up the ASCII table is man ASCII. Yeah. Cool. Don't want to go in there. Okay, so how networks actually work. So we talked on a very basic level about like networks, and like communication between networks. But I kind of wanted to go a little bit more in depth about like how a network actually works. So we're going to talk about the TCP/IP stack, and if you're in cyber, you probably might have heard this already. It's like the greatest thing on the face of the planet. Not really. Oh my god. Okay, so yeah. In an actual like network and like actual like communication between networks, it's basically broken down into these 5 layers. Okay, there's the application layer, the transport layer, the internet layer, the data link layer, and the physical layer. Does anybody know what any of these are already? Okay, so who can tell me what the physical layer is?
Like the wires between systems.
Yeah, so wires in between systems and wireless stuff as well, right? So off the top of my head, I know Wi-Fi goes on the protocol of 802.11. So its waves are on that frequency. And so that's how it communicates. Not frequency, but like what is it?
802.11 is the actual blue standard.
Yeah, yeah. So that's like how Wi-Fi communicates. But then he also said the actual wires, right? So like that's the Ethernet that connects it. So like this computer has an Ethernet cord attached to it, and that's how it sends information to the router. So this Ethernet cable is like indirectly connected to the router. It's connected to the floor, and then there's another cable that goes from the floor to the router. So that's like the physical layer. So like that's actually how it travels. At the physical layer is what is called, well, no, but at these 2 layers is what is called a MAC address. Every computer has its own unique MAC address, and it never changes, right? And it's a unique identifier, and it's 6 hex characters separated by colons, and that is how they communicate at a base level. The way they figure that out is a protocol called the Address Resolution Protocol, ARP. It's like a phone book essentially. So and it only happens within a network. So say I'm trying to connect from this computer to that computer, and I don't know its MAC address. I'll send out like an ARP request and be like, "Hey, does anybody in this network have this number or this MAC address?" And then that computer will respond back and be like, "I have it." And so that's how they communicate at like this base level. Any questions on the physical layer yet? All right, so who can tell me what the data link layer is? All right, that's fine.
Isn't that going from it goes from the physical to the network layer?
So yeah, it's like the intermediary step. That is correct.
It's everything within a local network.
Yeah, basically. Like, yeah, basically, right? So like, it is that's how they like communicate at the lowest level, right? So like, the data link layer and the physical layer are only going to be in between like my computer to the router, and then to the router to another computer, but never like my computer to another computer. That's not how it works. It has to go through the intermediary steps. It's not like a direct connection from computer to computer, unless it's like over like waves, like stuff like that. And so that's where the Ethernet, or that's where the MAC address also comes in. It's the data link layer. So the MAC address starts appearing here, and it in the physical layer is how it knows where to go. And you can see like that's where the actual like network media like goes through. Okay, anybody know? Well, they call it the internet layer, but it's also the network layer. So anybody know anything about that?
They can communicate to hosts on a different network.
Yeah, so that's how like these resolve connections to different networks. What you were going to say?
I was just gonna say well, I use IP.
Yeah.
IP.
Yeah, so and that's how we get to different networks, right? So this is like where the IP address comes in. So like the IP addresses can change, which is why like it's important to have a non-changing factor, which is your MAC address. But your IP address can be dynamic or it can be static. But this is how we go from different networks, which is why it's normally called the network layer. And so that's communicating to different networks and how that information is traveling. Okay, transport layer, anybody?
That uses TCP and what's actually sending data over the network, kind of.
Okay, so you are correct. It does use TCP, but there's another one. Technically, there's more than just two, but these two are the main ones:
Yeah.
TCP and UDP. Okay.
Oh, true.
So,
Yeah.
but like you said, right, the transport layer is how it sends the information, right? So like, internet layer, data link layer, and physical network layer, like that's concerned with like where it's sending that data to. So it's like, hey, like how am I sending this data in the physical layer? It's like, okay, in the data link layer, like what MAC address? And then in the internet layer, it's like what network? In the transport layer, it's like how am I sending this data? And the two separate ways to do that are TCP and UDP. TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. TCP is a connection-based protocol. So it goes and makes a connection. It's called a three-way handshake. It sends something, it waits for something to come back, and then it sends something back. They're called a SYN-ACK, and an ACK. ACK just means acknowledge, and a SYN just means like connect. Like, hey, like I want to connect to you. So that's concerned with like how it actually sends the like information. So like we were talking about, TCP makes an actual connection. It's secure, and it is supposed to guarantee that your packets are actually reaching the destination that they're supposed to go to. So that's cool. UDP, on the other hand, is connectionless. It does not make a connection. It just sends the data and is like, hey, if it hits, it hits. If it doesn't hit, like I don't care. So TCP is like, it's gonna wait for a response back to make sure that it got the packet. If the other computer responds that it didn't get the packet, it'll try to send that packet again. UDP, it doesn't care about a response. It's just gonna send stuff. It'll receive stuff. If it gets there, it doesn't. It gets there. If it doesn't, it doesn't. You may think like, oh, well, that's kind of dumb. What's the point of that? In certain circumstances, it doesn't matter, right? So UDP is good if we're trying to like stream videos or music or stuff. Like you can miss a couple bits like in that stream because like overall the resolution is not going to suffer too much. But that's like why resolution is bad, or sometimes your songs might buffer, is because the UDP is like kind of fucking up. TCP is good for like HTTPS or like email. Like you wouldn't want parts of your email to be missing. So that's like why TCP is used instead. Okay, anybody got the application layer? No?
Like a browser.
Yeah, so it's the browser. So it's the actual applications on your system. Another good example would be actually SSH. So these are like the actual protocols and how they communicate. So SSH or a browser, so like how a browser gets web information. HTTPS is in the application layer. All the like specifications for how the protocol communicates is in the application layer. And so essentially what happens is I'll start, say like I ask for a web page in this layer. It'll be like, okay, you want a web page. And so it's going to create a packet that's going to have like the information for the web page that I want to get. It's going to go down to the transport layer. It's going to say, hey, this web request needs to be a TCP packet. So it's going to wrap it in a TCP header. And then it's going to go here, and then it's going to be like, hey, it needs to go to this IP address and this port. And it's going to wrap it into an IP header. And what that process is called encapsulation. So it's going to encapsulate my packet up here, my data, into different layers so that when it gets sent over here, it's going to be finally wrapped in a physical layer header. And then when it goes up, it's going to de-encapsulate. So it's going to take each header, it's going to take the physical header, it's going to be like, okay, like this is the information from the physical header that I need to know, and it's going to send it to the right application. And then at the data link layer, it's going to be like, okay, well, it needs to go to this MAC address, so I'll send it to this MAC address. And then at the IP, at the network layer, it's going to be like, okay, like it has to be at this IP address and this port, so it's going to go there. At the transport layer, it's like it needs to go through this protocol, so it's going to go through there. And then finally at the application layer, it's like it needs to go to this protocol or this service, and it's going to go there. So like if it's the web request, like we said, it's going to go all the way through here. It's going to be like, hey, web server, I want you to give me the packet back for like the web page. And then finally, when it gets here, it's going to have that request stored here, and then it'll respond back to the proper information. And so that process of encapsulation, decapsulation is like how networks work. And it's kind of fundamental to understanding just like connecting to stuff, but like we probably won't see a good use of it for a little while. But is everybody clear on that? That's like basic, like that's basic Linux and basic networks, which is important to understand before we like go further into things. Any other questions on that? Okay, last thing before I take questions from everybody is so miscellaneous stuff. So before we do questions, we're gonna talk about Chmod and permissions. So on Linux or everywhere you have permissions. So like sometimes you can't access something if like you're not the administrator. The same is here. Like if another user makes something, you can't access that unless they give you permission. We can see the permissions of something by doing ls-l. I'm sorry, I need water probably. Does anybody know what like read, write, execute is? What this RWRX is? Hit me.
Well, it's basically like on Google Docs, it's a good example. Like just the different permissions you can have, like the levels of permission for a file. One is just to like view it, the other is to be able to actually modify its data, and then the last one is to actually like execute whatever it might be.
Exactly. Yeah. So just like you said, like it says you have the ability to read, you have the ability to write, you have the ability to execute. So you have the ability to read the file, you have the ability to write to the file, and you have the ability to like execute the file. Execute would be like for programs and stuff. It's broken down into user, group, and then all. So like the owner of this file can read and write to it. Everybody like in a group related to the user, everybody in the group domain can read this file, and all users can also read the file. So it also corresponds to here. So it goes the user who owns it, the group who has access to it, and then all users. So if I had a file that I could not execute, for example, the training PDF, for some reason I really want to execute the file, I don't know. I can use a command called chmod, which means change mode. And I can provide an option that tells it what I want it to do. So to make something executable, you have to do +X and then the thing. And if we then check ls-l, we can see that everybody now has the ability to execute the PDF. So there may be a program within Bandit that you might have to execute, and so that's how you change the permissions. But you may not be able to change permissions on all systems because you may have to have the sudo ability, and not all like systems will allow you to see that. Yes.
If you like chmod plus X the PDF and say like just CJ rows, does that only not execute
So
just X for you?
yeah, so his question is how can I make it so that it's only executable for the user? You can also make it only executable for the group or only executable for all. So let's remove the executable permission, which would be a -X, and then the thing. Let's make sure that worked. So if I wanted to make it just for me, I could do U, which means user. I said +X, and then I can say underscore training. And if I ls tech L, here, I'm sorry, I'll move this up. If I ls tech L, then I can see it's only executable for me. If I wanted to add a group, it is G, I believe. Yeah. And it adds it to X. If I want it to be everybody, I'm gonna do, and it does everybody.
I also have like a question on top of that.
Yeah.
If you just have the X, like the X people in the group, but not yourself, but you're part of the group, don't you have the executable function?
Yeah, so I just removed all executable. This, I make it group. I'm gonna clear the screen. So because I'm a part of the group domain, I now have executable permissions. But it could actually no, should I have it denied? Yeah. Cool. But I have the ability to change its thing now because I'm a part of that group. Okay. Anybody else have any questions about Chmod? Okay, so I promise we'll get started on the rest of the Bandit, but I wanted to see, does anybody have questions that they think would be good for the whole group about anything that they saw in Bandit or any like weird commands or like weird challenges? Or does everybody just want to get started? No? Okay, well, get started on Bandit then. If you have a question, I will be available momentarily. I have to go get somebody started on Bandit really quick, and then I'll come help in a second. What's up? Yeah, come over here. If you guys need to get started on Bandit, come over here.
Nice.
Oh,
Very nice.
What are you doing? Nothing. I just wanted to be able to read what the fucking says because I'm a bit short-sighted.
yes, if you haven't
Really
started
dark, so
Bandit,
tired.
and you want to
Yeah, you were
know
like,
how
I'm full of energy. I had a Red Bull.
I
And then
did.
I look over and you're
Dude,
like,
I was in and out. I had 3 hours of sleep.
Drifting
I
in
had
and out of
3 hours of sleep last night.
Whoa.
It's okay.